Welcome, everyone. This is day 3 of SX Live, and I'm here with Cassie. Super excited for this session. Cassie and I met, I believe, 2 years ago in Portugal, and we got to know each other. And I invited Cassie for this conference, and she graciously accepted to join this conference. A little bit about Cassie. Cassie is a chief decision scientist at Google. She has a huge following in LinkedIn. I think 500,000 followers in LinkedIn, I believe. And she also writes a lot of blogs about AI and also creates very compelling YouTube videos. So if you have a chance, check out her YouTube videos. She makes amazing content. Love the stuff you do, and Cassie, and so excited to have you. This topic that we have today, myths, facts, and opportunities for generative AI, is something that comes up in every customer discussion that I'm having these days. So much hype about AI, and rightfully so. I think the AI revolution is clearly here, and people want to understand more. This has business implications. This has societal implications. This has implications for not just one department in any business. Almost every department in a business is impacted by AI. So everybody's very eager to learn about AI in general, but more specifically generative AI. So I will let you take it away, and I'll be in the backstage listening to you.
Thank you for that introduction, Krishna. So this is me, and besides my day job as chief decision scientist, I do make a lot of content. So you'll see in the bottom of the screen, you'll see my social media tags and also my machine learning course, which Krishna mentioned, is called Making Friends with Machine Learning. It is designed to be friendly for everybody, no matter your level, whether you are an expert or complete beginner. We use comedy to get everybody on the same page. It's analogies until it goes deep. So join me for that if you like what's going on here. But this talk is definitely not about me. This is my colleague, Paul. And the talk is, of course, not about Paul either. This is Paul's wife's Aunt Dora. And the thing about Dora is that Dora is a computer. How do we know that? Well, it says so on her marriage certificate from 1950. And to spice this up a little bit, her husband's profession is clearly listed as engineer. So this is one of those early times in history where a computer has managed to marry her engineer. Now, I'm sure that I don't need to tell you that Dora's job does not exist today. No one is writing on their resume, on their CV, that they work as a computer. We have machines that now take over that role. So a question might be, what happened to Dora's job? Where did it go? Who automated Dora's job? And the answer here, we know what happened. This might be a little walk down memory lane, folks. So what happened was technology happened. Who automates jobs? And the answer to this is that software engineers automate jobs, but whose job does AI automate? That's a very different question. Now, before I talk about whose job AI automates, let's take a moment to dwell on the fact that if we are so concerned about the automation of jobs, why are we sitting by getting all up in arms about software engineering? I mean, that job is literally all about automating the work that everybody else does, because we as humanity are a tool-making species. We will make tools to help us do whatever we're doing better, faster, more efficiently, and tools that help us do what we can't do without them. And the thing about tools, folks, is that the point of our tool is for it to be better than us, to allow us to be better than we would have been without the tool. Any tool that leaves us the same off or leaves us worse off is a bad tool. And what we do as the tool-making species that we are is we toss that straight into the garbage can. So we have had tool makers throughout our history. That's how we got here today. That's why in this space, as opposed to a mud hut, and I don't have to hunt my food with a spear, even a spear is a tool, but we are fundamentally a tool-making species. And so when we are automating digitally, that job is typically called traditional programmer, developer, software engineer. Now we're ready to talk about whose job it is that AI automate. And there's a little delicious comeuppance here, because the actual job being automated is the software developer's job. That's right. The person whose job it is to automate everyone else's job is exactly the one who is being automated by AI behind the scenes. And then, of course, what's happening is not that the software developer is becoming irrelevant or going away, but the capabilities of what we can do with software are increasing so much that now there are forays being made into professions where it's almost a surprise that automation is possible. So that's really the exciting new difference today, that all kinds of things that didn't seem to be on the table for automation are. But to understand this clearly, why the job that's being automated by AI is the engineering job, let's go back to basics and ask, what are computers for? Computers are machines that turn input into output. How do they do this? Via a recipe that takes us from one to the other. And that recipe, so you can think of that as a set of instructions or a model, something in between that takes the input and turns it into the output. And the difference between AI and traditional programming simply boils down to where that recipe comes from. So where does it come from in traditional programming? Well, a software engineer has to think really carefully about the task. They have to ponder how to do it, what it would actually take to turn the input into the output. And then they write those instructions by hand after thinking about it very carefully. And the insight that you have to have here is, in order to automate the task, you have to understand how to do it. So, okay, you might be taking someone else's package off the shelf that they wrote, some code that they wrote, and you might be plugging that in, but still, whoever wrote that original thing has to have understood their piece of the task and has to have been able to come up with instructions for it. That's traditional software engineering. So the recipe in that case comes from handcrafted instructions. And the difference between AI and traditional programming, I'm going to summarize it in the next slide. It boils down just to where that recipe comes from. Instead of using instructions and saying, here's how to do the task line by line, instead we express our wishes with examples. Examples, not instructions. That is the difference. So instead of saying, do this, then do that, then do that, you say, here's a bunch of examples. Maybe you want to make an image recognition system that determines whether there's a cat or not in the image. And you would, instead of saying, oh, what is catness and what should I do with each pixel and how do I find the little, shapes that are triangles, maybe those are ears. Instead of doing it that way, you would say, hey, machine, here's a bunch of cats. Here's a bunch of not cats. Now you go figure it out. You go find the patterns that are common. You pull them out and turn those things into a recipe. And then once you've got that recipe, you're plugging it in a very similar way to how you would have plugged in your typical computer code. So that's the AI piece, the piece that lets you find patterns in data and turn that into computer code, into recipes. And a lot of things are actually the same after that process is done. Now you've got a recipe, it plugs in, and new inputs come in, goes into the recipe says what the output should be. Very similar to whatever the software engineer wrote, input comes in, output comes out. There are a few differences, and I'm going to mention those later. Primarily, the readability of the recipe is different. So when a human wrote the instructions, another human can easily read it. Quite often with machine learning and AI systems, it is inscrutable. It's too complicated. It's not written in a human-friendly form, so it's kind of hard to figure out how that recipe actually works. That's one of the big differences. But what I need you to appreciate is that what we are dealing with here is a communication revolution. And this applies to traditional AI. What I'm talking to you about now is traditional AI or core AI, enterprise AI from the previous decade. It's a communication revolution because it now allows you to express your wishes to machines two different ways. Notice how we do this with one another already. So if I want to teach you how to do a task, I could give you every single instruction. Or I could say, hey, watch me do it well a few times, watch me do it poorly a few times, and then figure out how to do it well. So we already teach one another in these two different ways, but we didn't have the ability to do that with machines. We had to only give instructions. That's the traditional software engineering approach. Now we're able to express our wishes to machines a second way. So it's an ungagging. We can now do what we were only able to do with one another, not with machines. We can express ourselves both of the ways that we want to express ourselves. Examples and instructions, which is really powerful because sometimes the instructions are really hard to come up with. Like, again, that example of what makes a cat a cat? What is catness? That's a whole philosophical pursuit. How would you write down the recipe for what makes an image contain a cat or not? But sometimes it's just so much easier to go, hey, can I come up with a bunch of examples? Can I tell if the examples were correctly handled? If I have both of those components, then amazing. That is such a great fit for a traditional machine learning task. Whereas if I can write the instructions and it's easy to write the instructions, we always recommend skip the machine learning, skip the AI, and just write the instructions. It's going to be easier to maintain in production. So what this is really all about is letting you automate the ineffable. If you cannot say what those instructions should be, you have a crack at automating the task anyway. And that is incredible. That is what all the AI enthusiasts have been getting so excited about over the last couple of decades. Now, a little bit of quick AI jargon to help situate you. In 3 words, common terms, if you see this in a system, you can have a guess as to what kind of functionality we're talking about. So if you see the words supervised, what we are talking about is getting the right answer. When we want a system to group similar things together, that's unsupervised learning. Reinforcement learning is about learning by doing. Now, a great example of this is when you play a video game. What do I mean by learning by doing? You learn your environment and how to succeed at your environment simultaneously, rather than you're given all the information plus the right answers and you're supposed to figure out how to get from one to the other. No, in a video game, you typically have something like a score or, did you clear the level or not? But you don't know how anything works. You're supposed to explore the world to figure that out. And so you try different things and you notice that your score is changing in a good direction or a bad direction, and that helps you adjust what you're going to do next. So that's reinforcement learning. And then finally, generative, when you see generative, that is about making plausible fakes. And generative AI is what we're going to spend the bulk of the time talking about today. And how does it relate to traditional AI? Is it traditional AI? Is it different? Is it the same thing? Why are we having an AI revolution right now? What has changed? So let's talk about that now. So what is the biggest myth in generative AI? In my opinion, it is that it is about AI. The spicy thing I'm going to suggest to you in this talk is that today's AI revolution is not an AI revolution at all. It is something else. So before I reveal that, consider the T in ChatGPT. That stands for transformer. The first paper about transformers was published in 2017, so 6 years ago. So this has been known for a little while. What changed? Why is there this recent blossoming, all this excitement recently? Because the capabilities were mostly there. That's not new. Well, here's what I'll say. If you were really excited by AI a year ago, then what you were excited by was the AI revolution, a true AI capabilities revolution. But if you've gotten excited about it in the last, say, 6 months, you're here for a different revolution. Not an AI revolution at all, but rather a design revolution, a user experience design revolution. What happened was that things that were only accessible to developers to help them write those recipes, write that code, is now being made easily accessible to the typical user. You don't need to know anything about AI systems. You don't need to be able to write code. You can suddenly interact directly with AI systems as AI systems. And the design revolution is that chat interface, that text box that everyone knows how to use for messaging their friends, that is now the way that you can interact with these really capable and interesting AI systems. That's the big revolution. This is a user experience revolution. The AI revolution has been going strong for a long time. And there is a little shell game here about where the AI actually is. From the perspective of those building the foundational systems, all the stuff that's behind the scenes that had to happen so that the user now has that interface that they can interact with. From the perspective of those folks who are actually using data to pull out patterns, to turn those patterns into recipes, this is business as usual. This is still AI. It's still automation at scale. But from the perspective of the user, it's almost like the AI bit is finished. And now what we have is apps with capabilities we didn't expect to have. That's the big revolution. That's what's changing things. But let me explain. Let's go a little bit more slowly into the facts, because it's very easy to get confused in this shell game. Think of it like this. Over the past 3 decades, there has been a different audience for the AI hype and a different group of voices talking about solving a different set of problems. And each group has been calling their thing AI, and it gets really complicated, very hard to navigate the space. So who's who and what was happening when? Let's take a look. So 2 decades ago, the epicenter of the hype was in AI research. So these were folks who were building general purpose tools to potentially be able to solve applied problems, to be able to create real solutions in the business world. But it was mostly theoretical. The ingredients were not there to carry it off. So it was theoretical, mathematical solutions as algorithms for pattern finding that someone else potentially could use to automate something at some point later. Mostly theoretical. Exciting, but mostly theoretical. And the reason I show this with nesting dolls is that it's not like that group goes away or becomes less relevant and important. It's just that it then becomes nested in a much larger group with physically more people talking about a different thing. So there will always be fewer researchers than the group that came next in the next decade, which is the builders. And by builders, I actually mean 2 kinds of people. I mean, not only the builders who are the engineers who are going to do something applied with this stuff, but also the builders, the designers, the architects, and those who are funding it with their wallets, the investors in this space. That's where the epicenter of the hype was. From the perspective of those folks, so what changed? Suddenly, there was a lot more data collection, and there was a lot more hardware to process it. And if we're going to be explaining ourselves with examples, which is fundamentally what AI is all about, well, then we need examples to be able to explain ourselves. So we need those massive data sets. And the reason that we're going to need data at scale is that we're going after those ineffable automations, those really complicated problems that it's so hard to write the instructions for by hand. Because every AI person knows if you can automate it by just stating the code out, that's how you should do it. That is the safest and most sensible way. So the reason you're using AI is that solving the task the old traditional way wasn't really viable. So we need lots of data. We need the hardware to process it. And the golden era begins about a decade ago, where suddenly being able to solve enterprise scale problems was on the table. And it tended to be enterprise scale in those days, because though it's possible to do applied AI, no one said that it was inexpensive or easy. My least favorite question in the AI space is, Cassie, tell me what the ideal worker in AI looks like. And I'll say, I hate that question because it's usually a team of people. It's not a one-person job. A big team that has all kinds on it, from statisticians to designers to machine learning engineers, analysts, and of course, the business decision makers. Will work together to create this solution at scale. And you as users on the internet, you certainly interacted with AI systems back then. Because during this golden era, all these enterprises were solving their at-scale problems, and they were doing this to create systems that were more efficient or more profitable, more delightful to the users, but they made the calls on how those systems should work. So let's say you used any Google product, there was AI in there somewhere, or something like Netflix, if you're watching Netflix, there is AI in there determining things like which content to recommend for you. But that's not in your face. You don't have to know that you're interacting with an AI system. And in fact, the design philosophy is kind of like, let's rather not tell them, let's have everything just work seamlessly. So you're already a user of AI systems. It's just that those AI systems were built to solve specific problems at enterprise scale, and you get to enjoy them as a user. And what's very different now in this decade is that the third group is, you guessed it, the users. The emphasis has shifted from the AI system being an enterprise scale system that solves only one problem, and the user has to kind of take it or leave it, to the problem being solved by the enterprises is to create essentially a raw material for users to interact with creatively. That's the big difference. And for users to understand that this is an AI system that they are interacting with downstream as an app or as a system built on top of one of these AI systems. But it's in-your-face AI, if you will. This is a very, very different philosophy. And I think it's worth really dwelling on the kinds of problems that we are looking at solving, that each of these groups is looking at solving. The researchers focused on theoretical problems. Theoretically, someone would use this algorithm to do something interesting with it later for their particular application. Think of this as creating, in a kitchen setting, creating a microwave and not worrying about the specifics of which kitchen this microwave is going to be used in, what particular foods it's going to cook. Just a good microwave that has good properties. Maybe someone will use it one day. And it's more like the blueprint for the microwave rather than the microwave itself. But so exciting to see what could be possible. Then, fast forward to a decade ago, the builders are solving these enterprise scale problems. At enterprise scale, because that tended to be the viable, feasible way to use AI. It's a whole symphony of effort. It tends not to be a one-person job. And so to do something valuable with it, it took a team. It took often curated data, quite a big investment in data. And so to carry it off, you needed to be solving a large enough problem, not an individual problem. And now today, from the perspective of the builders of the foundational models, the Googles, OpenAIs, etc. of the world, it's still that same enterprise perspective. We're solving a large business problem at scale, which is, can we or can we not provide these capabilities to our users? But from the user's perspective now, since the users are the most dominant voice, there are far more users than researchers and builders. From the user's perspective, this is all about solving their individual problems in individual and custom ways. So in many ways, nothing has changed. But in some ways, everything has changed because now individuals can interact with these systems expecting personalization and interacting with them as AI. And to show you individual problems being solved, let me show you what happened behind the scenes of this presentation. Now, I've been making slide decks since graduate school, so I'm pretty handy with it. I don't tend to use illustrators and other folks, but it still takes me a long time. It takes me a long time to pick my images from Pixabay. That's what I used to use. Instead of using an illustrator, I would pick images from Pixabay. It would take me a long time. I remember when I first started writing and when I first started doing lectures and not keynotes back then, but little talks. Back in those days, I would face the dreaded blank page and I would get such terrible writer's block. How do I write a script? This sounds so daunting. But I realized that if I had a little dictaphone, I mean, this is back in the old days. If I had a dictaphone, I could speak into it, then I could just ramble, I could play it back, and I could create a script by typing up what I've rambled. But that took forever. So if I wanted to make this talk, I could do that a lot faster with AI, and this is not generative AI. So first we're going to do a little app bingo. So this is Otter AI, and I'd ramble into a microphone and then simply upload that audio and get out a transcript that I can work with. But it's got all kinds of typos in it. The grammar is not quite there. That's not really the point of that app. But I'd love to clean it up and create a little bit of sanity there, turn it into something like talking points that I can riff off and create structure. So I put it through Google Bard. This is the Google Bard interface. And I've asked it to pull out some selected talking points. And of course, we always think for ourselves. We never let computers think for us. So I went through, I read this, I made some modifications, but it helped me structure this talk. And I've already saved so much time doing it this way. But wait, there's more. Instead of using Pixabay to illustrate my slides, I can instead use Midjourney. Midjourney is my favorite of the generative AI art tools. So I will put in some prompts and I'll ask for these nesting dolls. And don't get the impression that it's perfect first time. It never is. This is a highly creative pursuit. I have something idea in my mind's eye, and I can't express that myself with a paintbrush or a camera. But if I run these prompts and if I customize them, I play with them, if I go through this process 70 times, 100 times, I might zero in on the thing that I'm thinking about and make it reality without having to learn years and years of illustration skills. So this is me, a non-illustrator, being able to illustrate my deck with these personal productivity tools, which is incredible. It's a great revolution. And then finally, for fun, to show you the code capabilities, I'm using ChatGPT here as an example. Bard also does this. So I asked it to take a folder of PNG images that I had on my desktop and turn them into a GIF. And I do write code, so I could have written the code to do this myself, but how quick and easy it was instead to follow the instructions, so I didn't have to worry about that. So it tells me exactly what to do, what code to paste. I pasted that code, and the result is that I got to take all my attempts and get a nice moving picture to show you the attempts on this form of my robot nesting dolls. And of course, to even zero in on this form took forever. So anyone who says that the stuff takes the creativity out, you are still the artist when you are playing, when you're iterating, when you are trying different things to make your vision a reality. I think that it's having a similar effect in society as when the camera came out and people thought, well, maybe painting wouldn't be relevant. And painting is perfectly relevant today. It's just art has now expanded. If you look at the 20th century history of art, you'll see that there's a lot more possibility and play with new mediums that makes art a lot more fun. It doesn't kill it. And I think in the same way, creativity is going to have a flourishing as people without the technical skills, the painterly skills or the photography skills, are able to reveal their thoughts, their creative ideas, and share that with the rest of the world. So this is just some personal, individual productivity that I got out of these new tools. And how I'd suggest you start thinking about AI is not as artificial intelligence, like it's an entity or a robot, but rather as augmented individuals. When humans use these creative tools, particularly with generative AI, which is intended as a raw material rather than the finished product in that enterprise AI sense, when individuals play with this raw material and find great ways to enlarge themselves, empower themselves, and do more, they can become hyper-productive. They can cut down their time to getting things done. And they can unlock whole other aspects of their jobs, of their careers, doing things they didn't think they could do before. When you think about AI as an entity or a robot, I think you're missing the point of the revolution. Especially when it comes to generative AI, those systems are best used to enlarge a human's potential rather than to replace or remove the human entirely. Unfortunately, though, the human can get removed here, simply because if you have jobs that require there's a limited amount of stuff to do, and one of the workers, it used to take 10 workers or 20 workers, now one of the workers is 20 times more efficient because they've got access to these tools, then perhaps there's less to do for the others. So there are certainly going to be labor market changes. But if you're thinking of this as a bunch of robots quietly going and doing stuff on behalf of humans, you're missing the revolution where it's a few humans, hopefully many humans, who are learning quickly how to make themselves more productive, how to cut out the boring parts of their work and focus on the creative or interesting or nuanced pieces. So it's an upgrade that we're getting. It's a lot like the upgrade that happened when computers were available. A computer lets you do a whole lot more than you can achieve if you've just got pen and paper. But watch out for that FOMO that people have, that fear of missing out with generative AI. When people get so obsessed with which 10 apps were released in the last week, it reminds me of those early days in the 90s of those discs of video game demos and people asking, oh, have we collected them all? Did we manage to get them all by mail? Have we missed out on anything new? Now, imagine trying to keep track of everything in the App Store. That's not possible. That's way too much. In that same way, what is on the table here with generative AI for individuals is individual capabilities, individual productivity. And for everybody building on top of those systems, it is taking output and then shaping it and reshaping it to serve individuals again. So there's a lot more customization. That's where this is all going. There's a lot of work and effort cut down, and there are new capabilities on the table, for sure. But it's a flourishing of the human rather than a replacement by an entity. The more we anthropomorphize these systems, the more we're going to get it wrong, the more we're going to trust the wrong part of the system instead of testing the way that we should. So I propose that we say AI stands for augmented individuals. The revolution behind the scenes in capabilities and the big foundational models, still business as usual. If you're getting excited by this new stuff, it is all about design. It is all about individuals being able to do more with machines, just like the computer revolution. So let's talk about opportunities in generative AI. And we'll also look at this from the perspective of businesses who want to build on top of the stuff and investors who would like to figure out what to invest in, what's legitimate, how to think about the space. My favorite analogy for traditional machine learning is the kitchen analogy. Every part of the large-scale kitchen endeavor maps nicely onto traditional machine learning and AI. So data here maps nicely onto ingredients. If you are thinking about creating new and interesting recipes, if you're thinking of serving dishes to your customers, it's quite hard to do that if your data are rubbish. Garbage in, garbage out certainly applies here, and you don't get to skip over that, thinking that data are magic. We've got food, everything's going to be okay, right? Imagine chefs who say, oh, we've got food, we don't know where it came from, no one looked at the quality, no idea about the supplier, no idea if it's fresh or not. Everything will be fine because it's food with a capital F, data with a capital D, and it's magic, everything should be fine. No, the quality of your ingredients matters a lot. Then what the researchers do is they create blueprints essentially for the equivalent of the microwaves, stoves, etc. that populate the kitchen. And it's platform builders who will package those blueprints up into tools, algorithms, software libraries that developers can use to send data or ingredients through the appliances with the hope eventually of having a recipe that can be used to serve dishes at scale, and think McDonald's scale. Now, the recipe bit, that's the bit that traditional enterprise AI is trying to figure out how to do. Right? Take data, take ingredients, take a beautiful kitchen full of all kinds of appliances, and then figure out how to make gluten-free, vegan, Michelin quality, delicious croissant. How do we make the recipe for that? Well, there's going to be a lot of dabbling, tinkering, playing, and taste testing. Do we know that we're going to be able to do it for sure? Well, with the croissant, maybe that's a really high goal. Maybe it's a little far-fetched that you can get gluten-free and vegan and Michelin-starred and flaky pastry all in one thing. So there'll be a lot of dabbling, tinkering, and playing. It's not going to be guaranteed that you'll get the recipe that you're going for. But if you intelligently tinker, and you do it at scale, and you do it using the modern platforms, you have a shot at it. Even if you couldn't write down that recipe, even if you didn't know what it was going into it, you might, by dabbling and tinkering, discover a recipe that works and does what you need it to do. Now, of course, you had better perform a little taste test and taste that croissant or cookie or whatever it is before you're thinking about serving it to users. And this all is from the builder's perspective, traditional AI. And it's still traditional from the perspective of the Googles and OpenAIs of the world. What's different today, though, is that now those cookies are being taken away out of the restaurant, if you will, and repackaged into more interesting data products, more customized, serving a whole range of different needs than ever before. Or those cookies might be taken by the user and cooked with at small scale at home. Now that cookie is the basis for an ice cream sandwich at the individual level. This is the landscape today. And I think if you keep the kitchen in mind, you keep it much more in mind than robots, you will end up thinking sensibly about investments in the space and thinking sensibly about the dangers and what could go wrong, and also finding the opportunities. For example, if we're going to be doing this stuff at McDonald's scale, you'll notice that it's probably pretty hard to pull off every piece of this process, to be your own data supplier, to be your own inventor of appliances, to come up with the recipes from scratch, to first have to invent all the appliances, then figure out all the farms and logistics and all that, then create the kitchen, then start tinkering to create the recipes, and eventually get to serving those Valentine's Day baskets of cookies or whatever you have. If you encounter someone who claims to be doing that, like Google does this, we end up innovating in all of these spheres. But even for Google, this is hard. If you're encountering a smaller sized company that claims to be operating in the whole space and innovating in every single part of this, I would pause and wonder, and I would really ask the question of, which bit do you work on? It's very hard to be doing all of them yourself. So when you're talking about excitement about data or AI, which bit do you do? Do you prepare the data so other people could use it? Do you collect data, grow your ingredients? Are you a farmer? Are you inventing new appliances? Are you doing that core capabilities research? Are you innovating in the recipes? Are you innovating in these large language models, for example, to get a new kind of GPT or Lambda? That in this space is equivalent to innovating in the recipes. Or is this about taking dishes that are being served by someone else's recipe and doing something creative with them, doing something more customized, more unique? Instead of one cookie per person, the usual way, are we packaging it up? And by doing so, qualitatively changing the nature of the utility of the product, the delight of the product. And if you look at the leap from the chocolate chip cookie to the basket, That is more of a user experience leap. That is more of a creativity leap. How do I take this raw material that someone else has made, and how do I do something creative with it? That is the thinking. That is the dominant thinking of today. And so the people who are innovating on the edge of generative AI data products, they're typically working with someone else's outputs and doing things like filtering that output so that if it's outputted something irrelevant, the user won't see it, or doing something like adjusting the prompts. Maybe the user puts something in, there's some logic that takes place that adjusts what that prompt was to be something that would be a better fit for the system, so that what the system gives back is more relevant. So this is a very busy, complicated ecosystem, even though it looks simple, and then the simple analogy does hold. There's a lot going on. When you think about knowing about kitchens, knowing about food, having a rough sketch of it helps you orient yourself, but it's a lot harder to pull off the McDonald's kitchen at scale. Sure, you understand about farming, and you understand that the quality of your ingredients matters, but how do you make sure that those ingredients actually do arrive at the appropriate quality at scale? This becomes quite a hard discipline in its own right. So where are the opportunities? First, try to focus on one of the categories at a time. That's a big piece of advice here. And innovate, figure out where you're innovating and know clearly which part you're trying to do. Is it on the data? Is it on the models? Is it on the algorithms? Is it on the data products? And if it is on the data products, understand that you are probably better off hiring people who have a reliability background and a design background, and less so a cooking background per se. The cooking, if you will, is mostly being done by somebody else. How do we figure out whether we're not going to poison our staff, for example? How do we figure out our clients? How do we figure out whether our approach is robust to some ingredient changing, because somewhere where we couldn't control the whole system, a farmer ended up switching the type of rice from white to brown rice, and now we have to figure out how everything downstream is going to change because what we expected isn't what we're getting. So reliability is a big one, and design fundamentally is what can you do with it, and how do you create delight and utility in your users. Now, a quick mention about AI danger. When people think about AI danger, they think about robots, humanoids. There's way too much anthropomorphizing of AI for my comfort, because by thinking about those robot-y things, we distract ourselves from seeing the real potential and threat of AI. So the most dangerous thing about AI is you and me and anybody who thoughtlessly automates using these systems. The danger is the thoughtless automation and the people behind these systems who are using them thoughtlessly. When you think about traditional programming, in order to get your task automated, you have to painstakingly go through and write every single instruction, or some other human has to do it, but at least human eyes looked at every instruction. In machine learning and AI, behind the scenes, all of it boils down to just 2 lines. Yes, it looks like a lot of code is being written. That's because the tools are unwieldy. Behind the scenes, really, just 2 lines are being written. And those are, optimize this goal on that data set, go. This is a thoughtlessness enabler, because before I had to know how to do the task to automate it. Now I don't need to know that. All I need to know is, what's my goal? How do I know if it succeeds? What does good look like? And here are some examples. Okay, machine, you figure it out. Now this is wonderful, because at small scale, if I'm just automating something for myself, it allows me to be thoughtless, which means I get the job done without having to ponder so hard about how everything works. But this is also terrifying, because at massive scale, if I'm releasing this system to millions or billions of users, Similarly, I can be thoughtless and come up with a flippant goal, point to some ingredients whose quality I have not checked at all, and now I can affect so many lives with two possibly very poorly thought out instructions. So the most dangerous thing is the thoughtlessness. These systems allow us to have amplified impact, particularly if we are the builders of the big foundational systems. It allows a decision maker to scale themselves, to say, this is what I think success should look like. These are the examples that I think are appropriate to teach the system from. Those are two small sentences with two massive consequences. And when we allow ourselves to see AI as this sci-fi thing that thinks for itself, we forget that this is actually a way for individuals to express a wish, like wishing to a genie, to a magic lamp, to express a wish. This is what good looks like. These are the examples I want you to learn it from. To do that, potentially without skill and thoughtfulness, to have huge impact on the world. So it is our responsibility, if we're going to be building these systems, to re-inject that evaporated thoughtfulness, to put as much effort into each of those two lines as we would have put into the 10,000 or 100,000 lines of manually written code, to really think about, what should we build? Why should we build it? Why is this the good thing for the world? And which data set? What could be wrong with those ingredients? Are they appropriate? So this is an opportunity for amplified impact. And so now more than ever, decision makers should step up and make sure that they skillfully make these wishes that enlarge themselves. And of course, testing is crucial. People ask me, Cassie, why do you trust AI? And I say, no, I don't trust human written code. I don't trust AI. I don't trust people to do the task, not until I have tested everything and everyone. You hire somebody, it says they're a writer. Can they write though? Can they write what you need them to write? Can they write at the quality, the right tone? Just because they've called themselves a writer doesn't mean that you can trust them to do the job that you need them to do. And also, just because somebody else has found their performance adequate does not mean that they will work well in your environment and they will do the specific task that you need done. So what will you do? You'll interview them, you'll test them, you'll see their work, and you won't trust them until they've earned your trust. Your feelings should be exactly the same with generative AI. Isn't it great that there's someone or something with the potential to get your task solved? But please do not trust until you have tested. Testing is crucial. So anybody who wants to use generative AI to make decisions on their behalf, it's equivalent to picking a magic 8-ball and saying, I'm just going to do whatever the magic 8-ball says. That is not the smartest way to make decisions. The human in the loop component is quite important here. Testing is crucial to trust, but think about where and how and what we test. So if you are the original builder of the foundational system, testing your data quality is, well, it's easier for the farmer who knows a lot more about what happened to produce those ingredients. But still, when the ingredients arrive on site, you can test the quality. But when you have a cookie already made, how do you test the quality of the ingredients? What do you even know about the ingredients? Or a collection of cookies, who knows where they came from, in a Valentine's Day basket? And if there's a problem, if you get food sick, you're like, oh, maybe something's wrong with the ingredients. Can you tell which ingredient it was? Can you tell what precisely went wrong? There is an informational wall between you and whatever happened earlier. So you should watch out for that in generative AI systems, where you're really taking a raw material that someone else has made for you and using it for your own needs, and you don't really know very much about the process by which that raw material was created. Similarly, the quality of the algorithms. In order to test those, you typically don't use real ingredients. Like, think about building a new and better microwave. You would probably get a standardized glass of purified water Would it even be in a glass? Who knows? And you would see how different microwaves perform on that same uniform water. Would you know anything about that if you only see how these systems perform on your specific gnarly data? That'd be a different thing. And what if you don't see any of that at all because you never go into the kitchen? All you see is the data products that come out the other side. Again, a lot is going to be hidden from you. So how do you think about trusting that? How do you think about testing it? It's a whole different game, and it will be the same thinking that you will apply to the kitchen and to using food products at scale, dishes at scale, turned into data of food products. And finally, let's touch on the future of innovation. What are some consequences here? With generative AI, everything can become individualized and customized, partly because this is a raw material that is being given to people to do whatever they want with. The traditional enterprise solutions were largely oriented on, does this perform a single, usually of narrow scope, corporate goal well? To create more delight in the users of Netflix, for example, by giving them better recommendations of things they might like to watch. That is a goal that Netflix has set. The AI system is designed to serve that goal. Now, instead, the system is more like a raw material, and you pick your own goal, whether you are building on top of the system as a vendor or whether you are an individual interacting with those interfaces. You pick the goal, you figure it out. And as a result, there can be so much more creative and custom usage. Think about single user apps. The idea of creating a video game or an app where the target is just one person, that didn't really make much economic sense a decade ago. Now that is completely on the table. Total customization. Or let's think bigger. Think about the way that the internet is, the way that people interact with the internet. Which parts of that are here to stay? Is it necessary for there to be landing pages? Or could those things be generated on the fly with custom images and custom text that is customized to a user? Will it be perfect? Do there need to be safety nets? Very likely. But now, more than ever, individualization and customization is on the table, along with all these new capabilities. So those are the opportunities. The myths, in some ways, is that it is about AI. The recent revolution is about UX, less so AI, and that all of a sudden you have apps that have capabilities that you didn't think they could have. Huge economic and labor market consequences come out of that when we see that a lot of things are on the table for automation that weren't before. But the most recent wave is about design. And hopefully with that, we've got a few minutes for questions. Let me take a few questions as you get excited by the future of innovation. Thank you for listening to me. And let me see about questions. So what do I read there? So the question is about using generative AI to create synthetic training data, synthetic data being simulated data, for improving AI models, the more traditional, supervised, discriminative models. I would say that yes, there is certainly potential, and simulated data has been used for this purpose and has been used for this purpose for a while. The wider range of flavors that the new data could come in is a mixed bag. It's both a blessing and a curse. In some sense, when you made your traditional synthetic data, you would have to very clearly specify the distributional characteristics from a statistical point of view of that data, and you would spell out what your toy world would look like from which that data was pulled, and then you would be able to plug that into your systems to use how you like. And that is fundamentally fake data that is going to skew the performance of your model and hopefully skew it in a way that is palatable to you. What happens when you do that with generative AI is that you will get a lot more varied and interesting responses out of it. Like the difference between pulling from a bimodal distribution to a 1,000-modal distribution would be a lot harder for you to set all those parameters yourself when you're creating the simulation specs. But now suddenly you have this really creative thing that comes out. That's actually a mixed bag from a statistical point of view, because you will lose the fine-grained control of however you were trying to adjust your data set in the first place. And if this then gets into a loop of AI systems all learning from synthetic data, when real data comes in, you will have overweighted the system to expect a particular kind of fake output. And then if the real world doesn't actually behave that way, you have learned yourself into a bad model. The current generative AI models are representing real user data or real vendor data created by people who are tasked with doing particular snippets of writing specifically to train these models, but it comes from real humans. When it's based too much on generated data, we're actually going to lose a lot of the ability to handle the real world that makes these things as valuable as they are. So be careful with synthetic data. Make sure you've got a statistician on the team. It's certainly a mixed bag. Okay, let's see another question. All right, how do we overcome limited budget and need for quick results to move forward with AI or generative AI? So first things first. When vendors are selling to individual users or to smaller companies, you have, think of whoever built the very large foundational model has built it, trained it, makes it available, perhaps for a subscription fee, or perhaps not, perhaps there's an API and people are going to build on top of it. The economics there boil down to someone's going to build on top of it to sell it to someone. The ecosystem is frothing. This is what's worth realizing. It's not just a few McDonald's all cooking at scale. Now, smaller vendors or individuals can take what comes out, package that up, and do something with it, and hopefully offer it at a price point that makes sense for the smaller player who is the customer. It's not big players to big players only, and it's not big players serving a one-size-fits-all thing to users. Now there's a lot of opportunity for different vendors to go and build with what's available and offer something into the environment. If anything, being able to be a user or recipient or buyer of the benefits of generative AI is easier than traditional AI. It's a raw material, someone's building with it, and the way they're going to price it is so that you can afford it. If, on the other hand, you want to do traditional AI with the big teams solving big monolithic enterprise problems the old way, not building on anyone else's solution, then yes, that is quite hard to do. And that's why we didn't have such a renaissance of everybody doing it. There were certainly beautiful success stories, but it never felt accessible to everybody to just, get a team of 10, 20 people and get it done and, buy the data sets and so on. Now with data products, it's actually just being priced so that you can afford them. Be careful and do the taste tests yourself. Let's see, what have we got? Doctors using ChatGPT to communicate with patients. Do I see that working for support professionals too? Absolutely. This is a productivity revolution. There are smart ways, smart hacks for anybody to improve their own communication with these tools. I could, doctors could, support professionals could. You all do it in different ways. But when the focus is the individuals making themselves more efficient at their work and finding creative ways to use the tools to do that, there's a lot of opportunity, but it does take creativity. I mean, even things as simple as drafting emails or talks, drafting scripts, things we might think about the individual customer support person, but what about the manager who creates a whole lot of new drafts of new scripts that they don't have to come up with themselves? Instead, they can come up with thousands, read it all, pick the ones they like, and now that's the script to work with if it's the kind of organization that works off of scripts. There is a lot that could be done here. Okay, I think that is my time up. I had a lot of fun here. Thank you for having me, and I hope this was useful to you. Take care.